Morning, everyone. My name is Tarvin, and this is my group members.
Hello, my name is Dharmesh.
Hello everyone, my name is Arvin.
Hello everyone, my name is Duresh Harmin.
Okay, today we are gonna present about problem-based assignment topic 4, instruction set and assembly language programming. So let's start. So first question is about addressing modes and assembly program. So the first question is define addressing mode. An addressing mode is a method used by a processor to determine where an operand means data is located. It tells you it's tell the CPU how to access data, whether the data is in a register, in memory, or given directly in the instruction. Addressing mode provide flexibility for programmers when handling data in assembly language. So second question is list all addressing mode in the M68000 processor. The Motorola 68000 supports the following address mode, which is immediate addressing operand is given directly in the instruction. The second one is register direct addressing. Data is stored in a register. The example is move D1 DO. So the third one is address register indirect. The address register points to the memory location. So example is move A0 to DO. So the fourth one is address register indirect with post increment uses the address in the register then increase it after use. And then address register indirect with pre-decrement decrease the address register before using it. And then address register indirect with displacement adds a fixed offside of address register. So the next one is address register indirect with index and displacement uses an address register, index register, and offset together. Absolute addressing memory direct. Operand is located at a specific memory address. After that, program counter relative PC relative address is based on the current program counter plus displacement.
And now I'm going to explain about the example M68000 program, which is uh, add using at least three addressing modes. For the first one is org $2000, that is add using immediate register direct and register indirect addressing modes. So you can see that the move dot word hashtag 5 D0 is the immediate addressing, so do is equals to 5. So next is the move dot word hashtag 7 d1, which is the immediate addressing for d1 equal to 7, and which is next is the add word d1 d1 d0, which is the register direct. So you can see that d0 equals to d0 plus d1, the d0 is equals to 12. Then next is move word d0 is the register indirect, store result into memory pointed by A0, and finally it's the end. Next. And next, the fourth is example of M68000 program, which is using subtraction at least three addressing modes. And org 2000, and now they are going to use the subtraction using immediate register direct and register indirect addressing modes. And move word hashtag 20 d2 is the immediate addressing for d2 equals to 20. Then move word hashtag 8 d3 immediate addressing, so the d3 is 8 equals to 8. Then subtraction word d3 d2 is the register direct, so you can see the d2 equals to d2 minus d3 equals to 12. And the result, real result is the load memory address into a1. So move word D2 in bracket A1 is a register indirect, store in result into memory. And next slide.
Okay, so I'll be talking about the logical and arithmetic operation. So the first thing is describe every step in the assembly program in figure 1. So let me start. ORG $2000. 2000 program starts at memory location 2000H. And then move word $4AB7D1, load the 16-bit value for AB7 into register D1, and not WD1 performs bitwise not on the contents of D1. All bits are flipped to 1, 1 to 0, 0 to 1. And then move word $5E92D3, load 5E92 into register D3. Or word D2, D3 perform logical or between D2 and D3, results stored in D3. Add word D2, D3 at the contents of D2 to D3, result stored in D3. Sub word D2, D3 subtracts the contents of D2 from D3, results stored in D3, and the end. So this so and I'll be list sorry. So next I'll be listing all I'll be doing the list of all logical and arithmetic instruction in M6 8000. So logical instruction and or ER, not ND, ORI, ERE, TST, CLR, BIT, BCHG, BSET, BCLR. And for arithmetic instruction, add A, add I, add Q, sub A, sub I, sub Q, MULS, MULU, DIVS, DIVU, NEG, CMP, CMPI, CMPA.
Okay, now I explain about the question 2. That is, convert the expression to M68000 assembly. First expression 101111 multiply DA16 plus 1234. The step 1, convert values. 10111111 the equals to BF hexadecimal. So DADA the equals to DADA. So now 1234 is converted to octal in decimal and also hexadecimal. So the answer is 229C hexadecimal. Now the assembly code. The first of ORG $2000. So move word hashtag $000 BFDO the load binary number. Move word hashtag $DADA the D1 load hexa number and multiply DOD1 D equals to D1 multiply DO the was unsigned multiply. So now add word hashtag $029 C D1 that octal convert value.
So that's all from us. Thank you.
So we kindly ask apologize for the late response and late submission because of the audio failure in the previous videos we sent in the group.
Sorry, madam.
Sorry, madam.
Sorry, madam.